Hey everyone, welcome to this today's class in which we'll be learning about work energy power, one of the important concept in IBDP. So we see the work done whenever there is a force applied and the object moves in the same direction. We say work by this force. In this example, if the force is F is applied on this mass and if the object got displaced by a certain amount, we say the work is done by this force. The way we calculate. So in this example, this force is making the angle theta can be resolved into the two forces, F sine theta and F cos theta. That's the reason we take the force as F cos theta, and that's our displacement. If we talk about the unit for the work done, so since force is measured in Newton, displacement is measured in meter, and cos theta has the specific value. So this is what known as a Newton meter, which is also called as a joule. The higher units for the work done can be also written as kilojoule, megajoule, which is like 10 raised to 3 joule, 10 raised to 6 joule. And then smaller values are like millijoules and microjoules that you can use data booklet to convert them. Now there are like three conditions when the work done can be zero. So when there is no force applied, when there is no displacement happen, and if the third thing, when the force and displacement is perpendicular. So given an object or given a scenario, there are various forces could be acting on it. Let's say over here, if this is the mass m, has a mass of 5 kg, and let's say if its weight force is like 50 Newton, if I take G as 10, then there'll be normal reaction. That will be also 50 Newton. We have discussed about this before. Let's say if there's a frictional force of 5 Newton, and the object moves on the right by a displacement of 10 meter, then I can calculate the work done by the weight force, normal reaction, friction. So you can calculate the work done by the frictional force. Work done by friction will be frictional force multiplied with the displacement multiplied with the angle between them. So this time the angle is 180, and you can say 5 times 10 times cos 180. Now cos 180 is -1, and hence this will be minus 50 Newton meter or minus 50 joule. Whenever you see your work done is negative, that's the some form of energy loss. So we will discuss that later. The work and energy is the same concept. Moving ahead, yeah, one more concept over here is the force and displacement. The moment you see the force and displacement graph, this area under the graph is called as the work done. So we can calculate this area under the graph to calculate work done. AUTG, this on force versus displacement graph, that will be work done. So you can calculate that. You can try this question over here. So in this example, we write the work is force into displacement into cos of theta. You can see the force is 24 Newton, displacement is straight away 8 meter, and then theta is 34 degree. So you can get this answer and write it as a joule. Moving on the next segment, which is called as the energy. The energy is ability to do work. So there are like there's three forms of energy which we should be familiar with. The kinetic energy. This is the energy due to the motion of an object, and the way we calculate it is like half mv squared. We will see this elastic potential energy. That's the energy stored in the spring. So if we have a force versus extension graph, which is like a Hooke's law, again, the area under the graph will be the energy stored in the spring. And if you see in the data booklet, the energy, the elastic potential energy is 1/2 k into x squared, where the x is the extension in the spring, k is the spring constant. So it depends upon 1/2 kx squared. That's again given in the data booklet. Now, the third form of energy is the gravitational potential energy. If the guy lifting that object, you are increasing this GPE of it, and then GPE is calculated as m into g into the height difference between them. M is the mass, g is the gravitational pull of that planet, and then delta h is the height difference between. Here comes this next law of conservation of energy. The law of conservation of energy, LOCOE, that says that energy is neither created, you can't create energy, so not created, not destroyed. You can just convert one form to another. So if this pendulum is moving between these two ends, let's say A and then B, at the position B, it is slightly away or like slightly higher from the ground. So it has this GP potential energy at this point, position B. When it starts moving backward to the position A, all its GP will be lost to the kinetic energy. Assuming that there's no air resistance. We'll see over here, we can try this problem. So kinetic energy says that, like law of conservation of energy says that the total energy at the position must be constant. So if I say this position A and then B, I can work on this problem. So I'll try calculating this total energy at point A, and I'm going to equate that to the total energy at point B. Possibly energy at point A could be kinetic energy plus GPE plus EPE if there is any at the position of A must equal to the kinetic energy plus GPE plus EPE at position B. And if you say there is kinetic energy at position A, so one half of whatever its mass is, let's keep this mass to be m because mass has not been given. And when the mass is not being given, it is likely to get cancelled. So one half of m, and then gravitational pull, if I take it as 210, and then speed at the point A is 4 meters per second square. If GPE will be the same mass, gravitational pull, the height is 1. There is no potential energy or elastic potential energy in that, so I'll keep it as 0, must equal to the energy at position B. Its GPE becomes 0, its elastic potential energy is not there. So all this energy turns into the kinetic only. You can see the mass is getting cancelled from either side, and I can solve for this. So this becomes, that's the law of conservation of energy. So the energy is neither created nor destroyed, just converted from one form to another. That we can discuss it using this. So over here, the skateboard guy, if I release it from this point, you can see its energy. If I can measure it, its kinetic energy, potential energy, law of conservation of energy is applied. At the highest point, its GPE is highest. When it is dropping down, its kinetic energy is increasing, and so does its speed is increasing. If I keep this friction on, then its energy will be keep decreasing. You can see the thermal energy has been increasing in that graph as well. And eventually comes to rest. Moving to the next part, which is called as power is nothing but the work done upon time. So rate of energy transfer. Power is nothing but the energy upon time, or you can say the rate of energy transfer. And its unit is measured in joule per second, or which is also called as a watt. So here we can also write down the power as F into V into cos theta, because you can see the power is energy upon time, work upon time, can be written as Fs cos theta upon T. We know the displacement upon time is velocity. This you will find it in the data booklet, that power is equal to F into V. Again, the theta over here indicating that the force and velocity has to be in the same direction. So if the power is constant, the force must be constant, and then velocity also has to be constant. Then only the power gonna be constant. Efficiency is always determined about determined for the machine. So which is a ratio of how much is there's a ratio of the work output upon the total energy input. It is also the ratio of useful energy upon total energy into 100, and efficiency of a machine always lies between 0 to 1. So if I say if there is a machine it requires that input and it gives you the output. The output will be the useful output. So if I take this ratio, efficiency is basically the ratio of useful output upon total input into 100. That will give me the percent efficiency. So for example, if I say if a machine is 80% efficient, that means it only converts its useful output will be only the 80% of its total input. Or you can say that 20% of input is waste. That's how you can like elaborate. So every machine has the like efficiency. Greater the efficiency, better the machine is, and no machine can ever reach like efficiency of 100% because there will be always some form of energy has been lost. So guys, just to wrap things up, the work is work is done when the force into the displacement and cos theta. That's a formula. Energy, the like these three forms of energy: the kinetic, potential, and then uh, elastic potential energy. Power is basically the rate of energy transfer, and efficiency is the ratio of useful upon this total input. And efficiency will not have any unit. It is it's a ratio of the same quantity, so it doesn't have any unit of it. Thank you. I hope to see you again.